Welcome to World Prism. Please subscribe and hit the bell icon for more breaking updates. Our solar system is just one island in the vast Milky Way, but sometimes, a rare visitor from the galaxy arrives. On July 1, 2025, astronomers in Chile spotted 3I Atlas, the third interstellar object ever detected. This was no ordinary rock. It was a messenger from a distant star system, carrying secrets from a place we may never see. Observatories worldwide quickly focused on this fast-moving object, which was not bound by our sun's gravity. 3I Atlas was on a hyperbolic path, a true interstellar tourist passing through for a brief visit. Every observation was precious, a chance to study material from another world. Initial data suggested it was a comet, but it soon proved to be unlike any comet we'd ever seen. The discovery marked a new era. We're now finding interstellar objects, each a scientific lottery ticket. 3I Atlas was not just a passive chunk of debris, it was active, dynamic, and defied our expectations. Its size was staggering, far more massive than its predecessors, and it moved at incredible speed. This ancient object carried the chemical fingerprint of its birthplace, a place with a different history. Its story was written in a language we barely understood. We had to decipher its behavior, composition, and its strange defiance of the physical laws we thought governed all comets. The messenger had arrived, and it was speaking in riddles. The race to understand it had begun. Before 3I Atlas, we'd met two other interstellar visitors. 1I, Oumuamua, discovered in 2017, was a cigar-shaped mystery that accelerated away from the sun with no visible tail. 2I Borisov, found in 2019, looked and behaved like a typical comet, reassuring us that other star systems might produce familiar objects. Then came 3I Atlas, shattering any sense of pattern. It was neither a quiet rock nor a well-behaved comet. It was something else entirely. In scale, it dwarfed the others, possibly a million times more massive than Oumuamua, but its true significance was in its behavior. Unlike Borisov, whose activity was predictable, 3I Atlas was an enigma. It was active, but its composition was unlike any comet. Rich in heavy metals, poor in water, this visitor wasn't playing by the rules. Comparing the three shows the galaxy's diversity, Oumuamua was an anomaly, Borisov a confirmation, but 3I Atlas is a direct challenge. It tells us the galaxy is filled with objects stranger than we imagined. We can't simply classify them as asteroids or comets. 3I Atlas is rewriting the textbook on interstellar visitors. Each new object expands our sense of what's possible. The universe, it seems, is far weirder than we thought. To grasp why 3I Atlas is so unusual, we need to understand how a normal comet behaves. Comets are icy leftovers from star system formation. As they approach the sun, their ices sublimate, releasing gas and dust to form a glowing coma. The sun's radiation and solar wind push this material away, creating the comet's tails. Typically, a comet has two tails, a straight ion tail and a curved dust tail, both pointing away from the sun. The direction of these tails is crucial. They always point away from the sun, regardless of the comet's motion. Sometimes from Earth, a comet appears to have a third tail pointing sunward, an anti-tail, but this is just an optical illusion, a trick of perspective. The anti-tail is actually a trail of debris left behind, not a true jet of material being ejected toward the sun. This predictable behavior is a cornerstone of cometary science. The sun shapes every comet's appearance. Any deviation from this rule is extraordinary. 3I Atlas, however, broke this rule in a way never seen before. Its behavior forced us to question what we thought we knew. The distinction between illusion and reality became vital, and that's where the puzzle of 3I Atlas truly begins. What set 3I Atlas apart was its defiance of cometary law. Observations revealed a real physical jet of material erupting from its nucleus, pointing directly toward the sun. This wasn't a trick of perspective, it was a phenomenon that seemed to violate the laws of physics. Hubble first spotted the anomaly in July 2025, and follow-up images confirmed a jet stretching thousands of kilometers sunward. Normally, any material ejected toward the sun should be blown back immediately by solar wind and radiation. Yet, the jet on 3I Atlas persisted, maintaining its structure against the solar onslaught. This suggests the material is either unusually dense or ejected with incredible force. Neither explanation fits our current models. The sunward jet remains the most baffling feature of 3I Atlas. It challenges everything we know about how comets interact with stars. The mystery deepened with every observation. As 3I Atlas passed near Mars in October 2025, scientists seized a rare opportunity. The ExoMars Trace gas orbiter captured faint images and, more importantly, analyzed the comet's light for chemical clues. Despite the technical challenge, the data confirmed the object's trajectory and provided a new angle on its composition. The Mars flyby offered a unique perspective, complementing Earth-based observations. Even limited data added to the puzzle of its strange makeup. The encounter underscored how difficult and valuable it is to study such fleeting visitors. Every bit of information was crucial. The red planet's orbiters helped us glimpse the interstellar mystery up close. 3I Atlas is a catalog of cosmic oddities. Its chemical composition is startling, rich in nickel, poor in iron, and with a nickel-to-cyanide ratio never seen before. Even stranger, it's almost devoid of water, the usual engine of cometary activity. So what's powering its coma and sunward jet? The answer remains elusive. Its light polarization is unprecedented, and its trajectory is unusually aligned with the plane of our solar system. It even arrived from a direction close to the famous "wow" signal. Each anomaly alone would be remarkable. Together, they demand we rethink our models. 3I Atlas is massive, fast, and chemically unique. It resists easy categorization. The sheer number of anomalies forces us to consider possibilities beyond conventional comet science. This object is a cosmic riddle, and it's one we may not solve soon. The mysteries of 3I Atlas have sparked fierce debate. Some astronomers seek natural explanations, unusual dust, rare chemistry, or odd rotation. Others argue that so many anomalies at once suggest something entirely new. The sunward jet, nickel-rich composition, and strange trajectory all defy easy answers. As of October 2025, our window to study 3I Atlas is closing as it leaves the solar system. Only ESA's Jupiter Icy Moons Explorer may catch a final glimpse. The legacy of 3I Atlas is the questions it leaves behind. It reminds us how little we know about the galaxy's contents. Future missions will chase the next interstellar visitor, hoping for answers. For now, 3I Atlas returns to the dark, its riddles unsolved.